good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Subinda with another video. Alright, we are continuing on calculus differentiation. Okay, the subtopic is the second differential coefficient. So we are doing example questions B and C. So the essence of this video is to practice example B and C, where we'll find the d2y dx2, which is the second derivative, and then we're also going to find dy dx squared, proving that d2y dx2, which is this right here, is not equal to dy dx squared. They gave the two did not give the same answer, they gave different answers. Alright, so let us get on with the video for B. Alright, so it's not very clear. Let me get a different marker. So for B, we have our B right there, since A was done in the previous video. So y is equal to 4x minus 1 raised to the power 3. So to differentiate that particular function, what you would do is your dy dx is equal to 3 multiplied by that. So by now you should be familiar with it, so I'll not explain what I'm doing. I'll just provide the working. So 12 multiplied by 4x minus 1 raised to the power 2. This is your dy dx. Then your second derivative is when you differentiate this again. So d2y dx2 is equal to 24 multiplied by 4x minus 1. Alright, 2 the power 2 minus 1 will be the power 1, and then the derivative of the core will be 4. Okay, this number here is 4. And then your final answer for your d2y dx2 will be equal to, here we have 24 times 4, because the derivative here of the core is 4. Alright, so this would give us 24 times 4, 96 multiplied by 4x minus 1, like that. So that is your d2y dx2. Okay. This is your final answer, 96 multiplied by 4x minus 1. So this right over here is your dy dx. This answer that we found here is your dy dx. Then your dy dx, which has to be squared, is equal to 12 multiplied by 4x minus 1 raised to the power 2, everything being squared. Alright, how do you simplify this? What you simply do is you square the 12. So your d2y, your dy dx squared would be equal to 12 squared is 144, and then index of an index, you should just do 2 times 2, which is 4. So it will be 4x minus 1 raised to the power 4 as your final answer. 4x minus 1 raised to the power 4. So this answer and what we found for our dy dx squared are not the same, proving that dy dx squared is not equal to the 2y dx2. Okay, now we're going to the next question, which is C, and our C is y is equal to 1, you divide by 2 minus 3x. You write this in a different form, it will be y is equal to 2 minus 3x raised to the power negative 1. To differentiate this, it will be dy dx is equal to negative 1 multiplied by 2 minus 3x. Then the negative 1 will lose 1. You multiply by the derivative of the core, which is negative 3. Your dy dx would be equal to 3, you divide by 2 minus 3x, everything being raised to the power 2. And then your d2y dx2, which is differentiating your dy dx, would be equal to First of all, before we do anything, let's write this in a different form. 3 multiplied by 2 minus 3x raised to the power negative 2. So this, the same as that, I've just taken this, which was the denominator, up there so that we can differentiate it in its linear form. Alright, so this is your, you can just clean up, I think you can just clean up everything right here. Then to proceed, your d2y dx2, okay, d2y dx2 would be equal to negative 2 multiplied by the 3 will be a negative 6 multiplied by 2 minus 3x, everything being raised to the power negative 3 multiplied by the derivative of the core, which is a negative 3. Alright, so d2y dx2 would be equal to 18, positive 18 divided by 2 minus 3x, everything being raised to the power 3. That's your d2y dx2. Then when you find the dy dx as this, okay, that was our final answer for our dy dx. So let us clean up. And then they want us to square that particular answer. It's very simple. Your final answer for your dy, in this case, your dy dx, which has to be squared, is going to be equal to, you square the 3, you're going to have a 9, and then you square this expression that is down. It means just saying raise everything to the power 2. This, using the laws of indices, is an index of an index. You just multiply the powers, so you're going to have 2 minus 3x raised to the power 4 as a final answer, like that. This is your dy dx squared, that is your d2y dx2, and this answer is very different from this answer, proving that d2y dx2 is not equal to dy dx squared. Alright, this marks the end of this video. Thank you so much for watching. This has been Cornelius Binda with another video, and bye bye.